So in this video, we will be taking a look at how to derive an equation for force on a current carrying wire due to the magnetic field created by another current carrying wire. So these are the two wires, wire A and wire B. Now if these two wires are adjacent to each other, then wire B will experience a force due to wire A and wire A will experience a force due to wire B. So our task will be to derive an equation which will be applicable for this force. So how do we begin? Let us consider the force created by wire A at the place where the wire B is. So let us assume that these are apart by this distance d. So the magnetic field at a distance d due to wire A will be given by some equation, and that equation will come from the following uh, formula. If you have a wire, then the magnetic field at a distance d from the wire is given by B is equal to mu naught I divided by 2 pi d. So this is something that we will apply here. So the magnetic field due to wire A is equal to mu naught I whole divided by 2 pi d. Let me call this as IA. This is IA and this is I d. So now what will be the force the wire B will experience? So for that reason, let us consider the following. If you have a magnetic field in this direction and a wire in this direction with carrying current I of length L, then the force the wire will experience is BIL, considering that the wire is perpendicular to the magnetic field. So this is the formula. So the force B will experience due to A is given by the magnetic field due to A multiplied by the current in B multiplied by the length of the wire. So let us consider that we are talking about a section of wire which is L uh, in length. So both are L in length. This is L, the length is L, and this wire also has length L. So this is the force. Now force experienced by B due to A is equal to BA. BA is nothing but mu naught IA divided by 2 pi d multiplied by IB into L. So this is going to be the force experienced by wire B due to A. Fair enough. Now what we will do is we'll calculate the force due to B on wire A. Force on wire A due to B. So the formula will be BIL, of course, and B will be due to B, and I will be the current in the wire A, and L will be the length of the wire A. So what will be the magnetic field due to wire B? It will be again following this formula over here. B is equal to B is equal to mu naught I B divided by 2 pi d. So you plug that over here, mu naught I B upon 2 pi d into IA multiplied by LA, or simply L. Both are same. So I will just write here L. So FAB is also this much. Now you notice that FAB and FBA both have the same value. Here you have IA multiplied by IB, and here you have IB multiplied by IA. So both are equal, all other terms are the same. So we can write FBA is equal to FAB, okay, The only difference is that the direction of the force is opposite. So the direction of the force A will experience will be in this direction, and the direction of the force wire A will experience will be in this direction. So both are opposite in direction, and when two forces are opposite in direction, we give a negative sign over here. So this is another relation that we derive from the formulation we just discussed. So we have three boxes over here, and all the three boxes correspond to this derivation. So further we can have one more quantity over here. We can write force any wire would experience will be mu naught I 1 I 2 divided by 2 pi d. Any wire means in any of the two wires, wire A or wire B, and multiplied by the length of the wire. I mean, this length I can take it over. I can take it over here divided by L. So that is what we have. So force per unit length, I can talk about force per unit length, which is mu naught I 1 I 2 divided by 2 pi d. So this is another equation. So you divide the force by length and you get force per unit length. And this quantity becomes independent of the length of the wire. These are the equations corresponding to this concept. So I hope this video was helpful, and I thank you for watching.